Hi there, I'm Hao, and this is just another video of me solving random code problems. So let's begin. Given an n by n 2D binary grid, which represent a map of 1 and 0. 1 is the land, and 0 is the water, and we want to return the number of islands. An island is surrounded by water and is formed by connecting the adjacent land horizontally or vertically. So left, right, up, and down, right? You may assume that all four edges of the grid are surrounded by water. Okay, which means like outside of the grid here, is all water. Okay, and so we have the output of one here, right? So as you can see, we only have like one island here, right? Only one island here. And in the second example, we have three. So one, uh, two, and then three, right? Because the neighbor is only horizontal and vertical, so you cannot go diagonally, right? So how would we do this? So we can start from so like iterate through every node. So as soon as we found a one, right? So as soon as we found a one, we can run a depth first search on this node to explore the potential I to explore the island, right? So we can keep going like left, right, up and down, right? Right. So you can find the island here, island here, right? Keep going, right? Uh, and when we reach the water, we will just return, right? So, and as we iterate, we want to keep track of the visited node, right? Because we are looking at the first node here, and we explore the island. And when we got into the next node, we don't want to explore this island again, right? Because the island is already in our visited set, right? So this is our strategy there. And so another thing I want to do a little bit differently is instead of having a set, we can just save some space by setting the visited island to the water to zero hole here, right? So when we get to um, this node, right, we will look at the left, right, up and down, right? Uh, so that we're not gonna use the the first node again, right? Use the visited node again, right? And instead of keeping a visited set, we can set the space by just simply setting this node to zero. So the space complexity here would be constant, I believe, right? We just need to keep track of the max. Sorry, we just need to keep track of the number of the island, right? And the time complexity would be m by n, right? Which is the grid size here, because we visited each node once. Okay, so let's code this up. So there's two ways to do this, right? We can use depth first search, or we can just use a stack to do this iteratively. But I think the recursion solution is much cleaner. So let's go with that. So let's make some constant here. Keep that line. So columns is grid 0 dot line, right? And then we want to run the depth first search on every single node, right? So this is the column. Uh, oh, I should just use the variable, the constant I create. Okay, and we want to run the depth first search on each node, right, row and column. Okay, so what do you want to do? Whenever we found a node, right? So if the grid at row and column is a one, right? If we found an island, a one, then we want to completely explore that island by running the depth first search, right? So we can just run the depth first search on it, and we can also increase our island. So let island equal to 0, right? And we can come up here, right? So we have our DFS here equal to the row and the column, right? So what is our base case? So we are looking at the left, right, up and down neighbors, right? And we just keep doing it until we are outbound, right? So we need to make sure if it's inbound. If it is outbound, we will return, right? So if row is less than 0, or column is less than 0, row is greater than or equal to row, or column is greater than or equal to column. Okay, so we will return when we are out of bounds or when we reach the water, right? Which means that is the end of the island. So we want to return the width of row and column is not equal to a length, right? We can just return. But otherwise, we're just gonna keep exploring, right? We can run the DFS on the row -1, which is the left, right? The right, the top, and the bottom, right? And okay, we are missing one step here. How do we keep track of the visited node, like the land, right? As mentioned earlier, we can have a visited set here, right? But we can set some base by just like setting the visited set, the visited node directly to 0, which is the water, right? So we can set some space there. Okay, and that's pretty much it. Let's give it a try. And it worked. Submit, and we're doing very well with this paper. Thank you for watching.